Okay, so we're going to use this note sheet for 2 days. And so on the side where something is printed, it talks about pretty much all the properties of logarithms. Some of them we've already talked about, and then a couple we haven't yet. But this is good to have them all in one place. And so we're going to review this first one. So something that you guys learned before Thanksgiving was the inverse properties of logarithms. So logarithms and exponential functions are inverses of each other. And so if you have log base b of b to the x, you guys know what that equals? Okay. So remember, inverse functions undo each other. So the logarithm would undo the exponential part, and you would just be left with x. Right, and then it works the other way as well. So if you have some base raised to a logarithm with that same base, because they're inverse functions, they would undo each other, and you would just be left with x. All right, so we're going to do a couple of examples with those. So 3 raised to the log base 3 of 2x. What do y'all think? Should just be 2x. All right, and then the base of natural log is e. So the natural log of e to the x plus 1, just x plus 1. All right. Now the next two properties are brand new properties, and they're really like the bulk of the lesson are these two properties. And so if you have log base b of a plus log base b of c, so two logarithms separated by addition, we can bring them together as one logarithm. So it would be log base b of a times c. Right? And then, for example, we have log base 4 of x plus log base 4 of y. So we're going to bring it together as one logarithm. So it will be log base 4, and then you're going to multiply x times y. All right. And then the next one is the difference of logs property. So you have two logarithms separated by subtraction. What do you think you're going to use to bring them together? If you were just guessing. So for addition, we use multiplication. What do you think we're going to use for subtraction? Division. So it would be log base b of a divided by c. Okay, so then for our example, we have the natural log of x minus the natural log of 7. So it's one log, so just natural log. And then you do x divided by 7. Right. The next two properties are properties we talked about before Thanksgiving. So the exponential property. So if you have the logarithm of something raised to an exponent, do you guys remember what you can do with that exponent? We did it a lot when we were solving these exponential equations. Yeah, you can move it down to the front. So it's the same as n log base b of u. Now we're going to actually use it in the opposite way today. So when we're condensing, you don't want anything in front of your logarithm. And so we will take anything that's in the front, like on this example, and move it up to an exponent. And then what does it mean to raise something to the 1/2? Square root, good. So the better way to write that is log base 2 of the square root of x. Right, and then change of base. I don't think there's any change of base problems on this, but I just wanted to put all your properties together, and I really want y'all to remember this one, hopefully for the ACT next time you take it. But if we have log base b of x, and we want to change the base to just common log without a base, or log base 10, you would do log of the old argument, so x, over log of the old base, which would be b. Right, and we would do the same thing with natural logs, but it'll be ln of the old argument over ln of the old base. All right, and then we will do this with numbers. So we're going to do two parts. So A is going to be the common logs, so like this first one, and then B is going to be the natural logs. So what should go in the numerator? Log of 16 or log of 5? 16. So log of 16 in the numerator, log of 5 in the denominator. And the natural logs is the same thing, but with ln. Now there's like 3 examples we didn't do. We're saving those for tomorrow. We're going to do some more examples on the back. So I fit examples for 2 days on the back. I write pretty big, so I think you guys can do the same. So on the back, we're going to call this section 4.4, properties of logarithms. Right, and then today on all our examples, our directions are condensed. Sorry, it could be in the book. I think it says simplify to a single logarithm using the properties. But I'm just going to call it condense. Okay, so the first one we have is log base 2 of 15 minus log base 2 of 3. Okay, so these logarithms are separated by subtraction. So what are you guys going to use to bring it together as one logarithm? Division. So it would be log base 2 of 15 divided by 3, which obviously simplifies to log base 2 of 5. Right? Now number 2 is kind of different. So number 2, we have the negative log base 5 of 1/6. So this one is going to be similar to what we did on this one right here. So we have something in the front. When we're condensing, we don't want anything in the front of the logarithm. So we're going to move it up to an exponent. So what's that exponent going to be? -1. What does it mean to raise something to the -1? Or what does a negative exponent mean? Reciprocal. So 1/6 the -1 should just be, what do you think? Just be 6. So the best way, the most simplified way to write that answer is log base 5 of 6. All right, I'm going to have you guys try this next one on your own. So for number 3, we have 1/2 log base 4 of 49. All right, what y'all do with the 1/2? Made an exponent. And then what is 49 to the 1/2? 7. It's just the square root of 49, which is 7. So we are also going to need to practice more of these that have variables instead of just numbers. So let's look at number 4. We have log of 2x squared plus log of 5x to the 4th. Right, so this is 2 logarithms separated by addition. So to bring them together, what are we going to use? Multiplication. So we're going to multiply 2x squared by 5x to the 4th, and we're going to get 10x to the 6th. And that's it. All right, and then this one is kind of a big step up. So we have 2 log of x minus 4 log of y plus 1/2 log of z. All right, so before we bring these, I'm just going to do this step by step. So the more comfortable you get it, you might be able to just go to the answer, but I'm just going to do it one step at a time right now. So anything that's in the front when you're condensing, you need to move that to a power. So we have a combination of addition and subtraction, but we still can condense this to one logarithm. So we just have one log. And then because I have subtraction, I know for sure I need a fraction bar. And then I like to think of a negative log kind of like a negative exponent. So if it's a negative log, that argument is going to have to go in the denominator. If it's a positive log, then that argument has to go in the numerator. So are we going to put the x in the numerator or denominator? Numerator. All right, what about the y? Denominator. And then what about the z? Is the square root of z? And is it going to go in the numerator or denominator? Numerator. All right. What if I had another one that was subtraction? If we had like minus log of a. Where would the a go? It'd just go in the denominator and it would just be multiplied by the y. So that confuses people a lot. They like try to do another divided by, but just put it in the denominator, just multiply it by the y. Okay, so that is it. Your assignment I've already posted on Classroom on page 298. I want you to do 1 through 16.